Welcome home. I am Shweta Aloysius, here presenting on the seminar on the topic of optical Ethernet under the guidance of Mr. Thompson Davis. Uh, Next, these are the contents that you have to be discussing: the introduction of an optical Ethernet, what is optical Ethernet, and what are the historical backgrounds and building blocks of optical Ethernet, technologies based on optical Ethernet, and the application used in the optical Ethernet, and the advantages and disadvantages, and future developments, and this conclusion and references. First, introduction. And its optical Ethernet is a data service that provides connectivity between two or more locations using fiber optic cables comprised of thin glass or plastic strands. Fiber optic Ethernet transmits data via pulse of light through which travel from much faster than data sent as electrical signals over the copper wiring of traditional Ethernet. Traditional Ethernet cable. And so optical Ethernet is technology that combines high-speed data transmission capabilities of Ethernet with optical fiber as the transmission media. It is widely used in the telecommunication and data center networks to provide fast and reliable data communication. Mm, it is a technology that extends Ethernet beyond the local area network, LAN, and the metropolitan area networks, MAN and wide area networks, WAN. This Ethernet is technology used for the service providing offering and offers reduced network connectivity. And Ethernet connections are developed in three types: point to point, point to multi-point, multi-point to multi-point. This point-to-point communication technologies means that there is connection between Ethernet connection. Ethernet connection. There are two endpoints, and data is transmitted directly between these 2 points. And in point-to-multi-point connections involves a single point that connects to multiple remote points. And in multi-point to multi-point connections involve multiple endpoint communicating with each other. This architecture is more complex than the other two. That means point to point and point to multi-point communications, and is creating a mesh network topology. That means multi-point to multi-point communication, creating a mesh network topology. And various types of networks that can be used in the optical Ethernet communication. That means LAN, CAN, MAN, and wide area networks. And in the basics of optical Ethernet operates by converting electrical Ethernet signals into light pulses. That means that travels over optical fiber cables. This light pulse can be travel long distances without degradation, and they are not susceptible to electromagnetic interference or radio frequency interference. And there are two main types of optical Ethernet. That means active optical Ethernet, passive optical Ethernet. And main active optical Ethernet cable is cabling technology that accepts same electrical inputs as a traditional copper cable, but uses optical fiber between the connectors. That means you can use traditional copper cables in the cabling technology, but uses optical fibers. That means for connecting that cables to different cables to the output, they are using optical fiber for fast and high speed transmission of data. And the major benefits of active optical cable is that longer reach and higher bandwidth and secure reliable transport. And in passive optical Ethernet is an emerging local subscriber access architecture that combines low cost point to point fiber infrastructure with Ethernet. EPONs are, that means Ethernet passive optical networks, are designed to carry Ethernet frames. That means this data is transmitted through the destination by five frames at standard rates, and I'll utilize a single track fiber that extends from the center office to a passive optical splitter, which then connects to multiple optical drop fibers connected to the subscriber nodes. And move to the history of optical Ethernet. That means the optical Ethernet is first been developed first optical fibers. That means Corning Glass Works creates the first low loss optical fibers in 1970s. In 1973, the first optical fiber transmission system is installed by Bell Laboratories. The researchers at the Bell Labs were among the first to explore this idea. That means in 1972 through 1980s, 83, they successfully demonstrated the first transmission of Ethernet trap signals over optical fiber. fiber. This breakthrough marks a significant milestone in the development of optical Ethernet technologies. That means in 1873, the first transmissions of optical fiber is being developed by the Bell laboratories, and in the 1880s to 1885s there are different modes of, that means different data rate of the optical Ethernet using the coaxial cable, copper to pair cables, by establishing the Ethernet communication by IEEE 802.3 standards have been developed in 1980s, and 1987, sorry, 1980, 1987, fiber distributed data interface that is introduced. High speed, that means this is a high speed optical networking technology for connecting in a LAN, that means in a common room, in a single room of connection. There are different computer different systems are being interconnected each other. That means it's position of a in small area, that means local area networks, they are connected the different computers, that means LANs, and operating at a 100 megabits per second. And in 1990s, optical Ethernet, that means optical Ethernet is introduced initially multi-mode fiber for shorter distances. And that means what is this? And next in 1992 synchronous 1992 and 1993 synchronous asynchronous digital hierarchies are introduced. In 1995 there are first 10 gigabits, that means different modes of bit rates of Ethernet communications are be developed using the IEEE 802 point protocols used with the multimode fiber optical cable. And in 1996 the dense wavelength division multiplexing is introduced, and in 2006 there are different modes of 40 gigabits Ethernet and 100 gigabits Ethernet and 400 gigabits Ethernet has been developed. In 2000 centuries, 20th centuries, different modes of optical Ethernet cables have been developed using copper twisted pair cable or single mode fiber optic cables, or single optical Ethernet cables are being generated. That means 800 gigabits now till 1.4 terabit Ethernet standards have been still developed, and means the more developing is being going down to the future. And the building blocks of optical Ethernet. There are three basic building blocks that can be used to construct on optical Ethernet network. Specialized optical Ethernet network technologies will vary depending upon the needs of network operators, and in many cases, many may include a hybrid approach that leverages multiple building blocks. And that means the technology which delivers high speed data communication with storage facilities and enhanced video and audio applications is termed as optical Ethernet. And the flexibility of and simplicity of Ethernet and speed and reliability of optics is combined to enhance the data transmission capability in optical Ethernet. And optical Ethernet building blocks are Ethernet over fiber, Ethernet over resilient packet drawing, Ethernet over dense wavelength division multiplexing. These are the three building blocks of optical Ethernet. And first, Ethernet over fiber. That means the first building block is Ethernet over fiber. This implementation is simple electrical to optical transmission. That means electrical to optical transition over a dark fiber. And it can deliver functionality over point to point and mesh network technologies. And this Ethernet over fiber is very cost effective, high performance solution and can distances as greater 70 kilometers. And Ethernet over resilient packet ring is a second building blocks of optical Ethernet, is deployed in a ring topology and can take advantages of existing SONET infrastructure. And the benefit of this type of implementation is that it solves the traditional problem of SONET rings. Bandwidth is utilized in the both directions instead of only one. Additionally, Ethernet over RPR, that means resaline packet ring, takes advantages of sonnet sling layer protection and provides less than 100 milliseconds failover. The RPR ring can span thousands of kilometers and provides a flexible multi-service optical Ethernet implementation. And the last, this are Ethernet over dense wavelength division multiplexing utilizes dense wavelength division multiplexing at its core transport. To transporting signals with wavelength mode, it delivers massive bandwidth for data point-to-point mesh or ring implementation. Ethernet over DWDM is particularly effective in high bandwidth, extreme performance scenarios such as information storage solutions or data center interconnection. Ethernet over DWDM is byte rate and protocol independent that allows it to work in almost any network scenarios. And all this this hybrid mode, this building blocks can also be merged together in hybrid implementations. That means topologies can be combined as well, blending point-to-point ring or mesh topologies to deliver unique functionality. Every corporations and service providers have unique requirements and objectives for their network, and optical is flexible and adaptable enough to fit almost any circumstances. And these are the communication technologies that can be used in this building blocks. And next, what are the key optical Ethernet technologies? And what are the key optical Ethernet technologies? That means PAM for modulation. This modulation, that means pulse amplitude modulation, is a modulation technique that encodes multiple bits of data into each symbol. It is used in optical Ethernet to increase the data rates of communication. This modulation is used, and there have been signal speeds up to 400 gigabits Ethernet. And in single mode and multi-mode fiber, the optical Ethernet networks uses different types of optical fiber. Single mode fiber, that means is used for long distance. Single mode fiber is used for long distance connection due to its low signal attenuation, and multi-mode fiber is used for the shorter distance between data centers and buildings. And in silicon photonics. In silicon photonics, technology integrates optical components such as lasers, modulators, and detectors into silicon-based semiconductor chips. This integration reduces the cost of optical transceivers and improves the performance. And wavelength division multiplexing. That means this is the building block. The communication system is used for the building blocks of Ethernet over DWDMS, and wavelength division multiplexing technologies enables multiple data streams to be transmitted simultaneously over different wavelengths of light on a single optical fiber. This significantly increases capacity and efficiency of optical Ethernet networks. And Ethernet over fibers, that means refers to use of optical fibers to transmit Ethernet data frames. It includes various Ethernet standards such as 10 gigabits gigabit Ethernet, 40 gigabits Ethernet, 100 gigabits Ethernet, utilizes fiber optic connectivity. And it's optical switching. That means optical switching is used for the optical Ethernet network to route optical signals. That means it can be using for routing the optical signal without the need for conversion to electric signal. That means optical switching then communication between two opticals without any conversion of electric signals. This technology reduces latency and power consumption in network operations. And the applications, there are different types of applications. And first one, data centers. That mainly the optical fibers are used in the data centers more. They will be more advantages. They are taking more advantages over the optical fiber cable communication. That means optical Ethernet connects our servers to switches, storage arrays, and other data center components. It enables the rapid exchange of data, ensuring the applications and services run smoothly. And in this data centers, the backbone of the digital economy rely on optical Ethernet for the high bandwidth connectivity required for the cloud computing, big data analysis, and artificial intelligence application. This optical Ethernet provide the capacity to handle the massive data. That means massive data flows generated by different applications and ensure the seamless transform of information between servers and storage. In telecom networks, that means in enterprises networks, that means telecom networks, operators use to connect central offices, cell towers, and network aggregation points in telecom networks. And this communication infrastructure of business and organization utilize optical Ethernet to support the growing demand for video conferencing, file sharing, and other bandwidth intensive application. And next in 5G and mobile, in 5G and mobile backhaul. Optical Ethernet facilities the transport of 5G traffic, including massive amounts of data from IoT devices, mobile applications, and it ensures the 5G services such as augmented reality, virtual reality, and autonomous vehicles can operate seamlessly. And this backhaul means the connection that flows from wireless cell site to the internet. That means the connection between wireless cell to internet is that backhaul. And in metro and long haul networks, that means in metro and long haul networks, optical is used in the point to point and point to multi point connections between metro areas, data centers, and other network facilities. The different types, different applications that we have been relating this. That means service provider backbones emerging, supporting high performance computing, enabling video streaming and broadcasting, connecting industrial automation systems, supporting smart grid infrastructures. These are the different applications. Optical impacts extend beyond the specifications, providing the underlying infrastructure for the digital transformation of various sectors, including finance, healthcare, education, and transport. As the demand for data continues to grow and new application emerges, optical Ethernet will remain a critical technology for enable seamless and efficient data transmission across the globe. And next, what are the advantages of optical Ethernet? That means higher bandwidth. Optical Ethernet support data rate up to 400 gigabits and beyond. Significantly higher than the 100 gigabit, 10 gigabits that is typically supported by copper-based Ethernet. This makes optical Ethernet a good choice for applications that require high-speed data transmission, such as cloud computing, high-performance computing, and video streaming. In long distance transmission, that means signals can travel much faster than copper-based Ethernet signals without degradation. This makes optical Ethernet a good choice for connecting devices that are located far apart, such as data centers that are located in the different cities, and in reduced crosstalk and interferences. Optical Ethernet is not susceptible to EMI and RFI, which can cause problems with copper-based Ethernet in environments that are prone to electric noise. That means electric noise has been interfaced with while transmitting with copper cables, but this makes optical Ethernet a good choice for the industrial settings such as factories and manufacturing plants. And there are low costs. The cost of optical Ethernet equipment have been declined in the recent years, making this cost effective for solutions of many applications. And scalability. Optical Ethernet networks can be easily expanded to accommodate additional bandwidth requirements by adding more wavelengths or increasing the data rate per wavelength. And quality of services. That means optical support advanced quality of services features, allowing network administrators to prioritize critical data traffic and ensure optimal performance for essential application. Wide ranges of application. Optical Ethernet is versatile and suitable for various applications, including data center internet, interconnects, metropolitan area networks, high-speed internet connecting different buildings within a campus or an urban area. And disadvantages. And mainly in the cost is advantages and as well as disadvantages. Advantages means this coming generations, optical Ethernet usage is being more relevant to the society. So but the initial cost of optical Ethernet cabling and the transmitting switches are very expensive, so that initial cost only being more expensive than the back and balance maintenance and the other costs have been reduced. Security. The optical networks are more vulnerable to security threats than copper-based Ethernet networks, and its complexity. Optical networks are more complex to design and manage than copper-based Ethernet networks. This is because fiber optic cables are more fragile and difficult to work with the copper cables. Fragility means the optical fibers are delicate and can break or become damaged if subjected to excessive bending, twisting, or physical stress. And uh, in case there are different challenges faced by optical regions in future. That means high initial cost, installation and maintenance complexity, fiber optic infrastructure. That means requires the installation of fiber optic cables, which can be expensive and challenging to install in certain environments. It can limit the breach of optical Ethernet networks, make them impact practical for some application. Power consumptions, limited flexibilities, and signal degradation over long distances. That means these are the different challenges. And in future developments, higher data rates. The cost for higher data rates will continue beyond 400 gigabits. That means of more than 400 gigabits and 1 terabits per second or petabit. That means 10 raised to 14 bit per Ethernet standards may be emerging to meet exponentially increasing demand for bandwidth in data centers, cloud computing, and 5G networks. And in network securities and enhanced the security measures such as in inline encryption, intrusion, detection, and protection against cyber threats will be integrated into optical Ethernet solutions to safeguard data during transmission. And some of the companies that can be used in the optical Ethernet for the communication, Sena, Cisco system, Adva optical networks in our network. This sort of the companies have been concentrated to the transceivers, switches, routers, that for the communication parts and the copper optical fiber cables and the connectors for the different applications. And this is and and conclusion, to come up to the conclusions, really the optical fiber is a vital networking technology that provides a stable and high performance solution for data transport and communication. As we go through the continuously evolving digital communication landscape, optical Ethernet continues to play an important role in a variety of sectors and applications. Its major characteristics including as high bandwidth, low latency and dependability led to its broad acceptance and success in powering contemporary devices. The use of optical Ethernet has transformed data centers, allowing for quicker and more efficient processing of massive information. And in essence, optical Ethernet is a cornerstone in modern networking design, allowing a diverse varieties of applications and industries through this high-speed, scalable, and stable connectivity. The advancement of optical Ethernet technology is expected to determine the future of digital communication, enabling the creation of faster, more efficient, and linked networks for the benefit of the society as well. These are the references that we've been using for the contents of these slides. And thank you.